Welcome everyone to LearnCity. We'll actually be moving on with our course in mathematics today. So we'll be moving on and be reiterating the laws and the rules of indices. Actually today we'll be looking at different topics that are being tested in the levels of WAEC. WAEC, we will be looking at different past questions and previous things that has been tested in years past. We'll be looking at laws of indices, logarithms, and sort in mathematics. So we'll be looking at this from the aspect and perspective of what your examiner requires you to know in O-level, mainly WAEC, NECO, or JAM. But we'll actually be basing our scope of study on WAEC this period. So we're looking at indices, logarithms, and sort. Now, the laws of indices. Indices is actually a very simple thing that is being tested at the levels of JAM, the level of WAEC, or the level of NECO. Now, if you still remembered some things that is being reiterated in our previous section, I said there's nothing hard in all these laws, there's nothing hard in all these rules. The only thing that you need to know is how to apply the rules appropriately, an ability to be able to deal with different technicalities that the examiner might pose to you. Now, I would like us to look at different rules in indices, and after that, we'll look at some examples in the past questions and other text or materials and resources available. Number one rule of indices is what we refer to as the additive rule, or probably what we could say a situation in which multiplication changes to addition. I thought and I believe that these are just rudiments which you ought to have been familiar with. For example, rule of indices says if we're having a raised to power n times a raised to power m, can you say the rule of indices allows us to simplify this further to a raised to power n plus m. What have taken place there? The multiplication sign have changed to plus. Another thing is that instead of using the two bases, what we did is that we picked the base, which is accepted by the rule of indices. Forget not that there is actually a criteria or an engine point to be able to apply this rule. The base must be the same. In a situation whereby we're having a raised to power n plus times b raised to power m, it will be inappropriate to say probably maybe ab raised to power n plus m. No, it is inappropriate. Indices does not accept that. The rule is that the base must be the same. The base must be the same. And I want to believe you're on the same page with me. Another rule is what we could refer to probably as the subtractive rule, in which a raised to power n divided by a raised to power m is equals to a raised to power n minus m. I know you must have been familiar with all this rule. They are just basic rudiments we need to accomplish before moving forward and forward in our course of study. Another rule is the inverse rule that says that a raised to power minus n is equals to 1 all over a raised to power n. Now note this, anytime you come across minus in indices and the minus is in power, the minus is signifying an inverse. Are you getting that? Or probably what we refer to as a transpose, or something that is actually going to change position. Do you understand that? For example, if you're having another situation of probably 1 all over a all raised to power minus n, this actually means, don't forget what I said, minus signifies 1 all over inverse. So to actually clear this minus, we say 1 all over the figures that we, the wordings that we have there before 1 all over a, then don't forget this minus will not be there again, then we have raised to power n. In other words, by the time you simplify this further, we have a raised to power n. These are just basic rudiments you need to be aware of. So another rule of indices is the power rule. The power rule. And don't forget what I said, there's nothing technical about these things. There's nothing art. Even in mathematics as a whole, mathematics is one of the most simple subjects so ever. The most important is you understand the rudiments and the application of relevant theories attached with it. Now, another rule of indices is what we refer to as the power rule. For example, a situation whereby we are having a raised to power m all over n. Now, in this situation, the base is actually a. The power is m all over n. Now, how do we simplify this further? The rule of indices says that the denominator actually should be a root of the base. That is, in this case, we'll be having nth roots of a. And m is going to be to the power of a. Can you see it? There's nothing adhering, it's just the application of some theories and concepts. The denominator becomes the root and the numerator becomes the power. Another thing that we have is a raised to power m or raised to power n. In this situation, we could say this is a raised to power m times n. So, according to what I said, there are varying rules in indices. There are different rules, but all still boils down to these basic rules. So I'd like us to take some examples in this regard. Then we'll look at some rules in logarithm and then some rules in sort. Then after everything, after a kind of brief overview of them all, we move to the past question. Don't forget to like, to share, and to subscribe to this channel. Let's take some illustration. Illustration 1. 4 raised to power minus x times 16 raised to power 2x minus 2, all divided by 4 raised to power 2x minus 3 times 128. Now, the question actually wants us to do one thing, and the main thing that needs to be done is to simplify this further. Looking at these two technical, these two ambiguous, but it can be brought to actually the lowest terms. It can be simplified further, it can be broken down further. So what do we do now? We apply the rule of indices. Now, when you are confronted with indices in your exam, peradventure it is in the objective section or probably in the theory section. And they will always put in your mind that the first thing you need to do is find a medium to convert all to the same base. Every of the figures you have, every of anything that you're actually given, find a medium to actually make them to align in the same base. Don't forget that the rule of indices can only be applied only if all are uniform, if the bases are uniform and is only under this note or under this point that we could actually apply the rule of indices. What we do next is how can we actually convert all to the same base? Actually, we can convert everything here, either 416, 4 or 128 to base 2. Now let's convert it to base 2. In this case now we have 2 raised to power 2. Don't forget that's 4 actually. So in bracket minus x. Minus x. That's the power that we have theorem before. Multiplied by 16 is actually 2 raised to power 4. Then you put in bracket 2x minus 2. All divided by 4 is actually 2 raised to power 2. Then in bracket 2x minus 3. Multiplied by 128. 128 is 2 in 7 places. 2 multiplied in 7 places gives us 128. That's 2 raised to power 7. Then from this henceforth, you could then open the bracket. Open the bracket. So you could see what have been done. What we did, there's nothing special there, is that we converted all to the basis of 2. Anytime you are given an indices question, the first thing that you always note is how did you convert all you were given to be in the same base. Only through this uniformity can we adopt or apply the rules of indices. So from this, then we can then open the bracket by saying 2 raised to the power minus 2x times 2 raised to the power 8x minus 8, all divided by 2 raised to the power 4x minus 6 times 2 raised to the power 7. Now, at this point yonder, we could actually then apply the rule of indices. And what does the rule of indices says? It says that times changes to plus and division changes to minus. So we say 2 raised to the power minus 2x. These times, don't forget, we change to plus, then put in bracket all the power of the second base, 8x minus 8, all divided by 2 raised to the power 4x minus 6 times changes to plus, that's plus 7. So you can simplify further by saying that 2 raised to the power minus 2x plus 8x minus 8, all divided by 2 raised to the power 4x minus 6 plus 7. So we are simplifying further. We say that 2 raised to the power minus 2x plus 8x, that's 6x, then minus 8, all divided by 2 raised to the power 4x plus 1. So we will simplify further by saying this division now, we can now remove it. Don't forget, the rule says division changes to minus. Just write a 2 signifying and representing the two bases, then put in brackets, put above 6x minus 8, then division changes to minus, then put all the power of the base that is in the denominator, put them all in brackets. That's 4x plus 1. So that's going to be 2 raised to the power 6x minus 8, then open the bracket with minus 4x minus 1. So from here we could say 2 raised to the power 6x minus 4x is 2x, and minus 8 minus 1 is minus 9. Thank you. This is a simplification of the question we are given. Now let's take one more question, then we move to the law of logarithm. Then don't forget, this section is actually to give a brief overview, because I believe that everyone watching will actually have a concrete knowledge and idea of this foundation that we are actually buttressing. But after all the brief overview, then we move to the different past questions. Let's take one more question to this regard, and then we actually move to the law of logarithm. Now let's look at the question. A question says, solve this simultaneous equation. Now don't forget, indices could be applied in different formats. A question could say that in the format of a simultaneous equation, a question could give you in the format of you factorizing. A question can come in any perspective. Just don't forget, the only thing that you need is the ability to be able to decipher the technicalities behind what the examiners want you to do. The question says, solve this simultaneous equation, 2 raised to the power x multiplied by 4 raised to the power minus y is equal to 2, and 3 raised to the power minus x multiplied by 9 raised to the power 2y equals to 3. So now in solving this, normally this is a simultaneous equation which is to be solved. But in solving this, the only thing that you need to do is, don't forget, change each of the lines of equation all to be in the same base. It's only when they are in the same base you could actually carry out anything or any rule of indices or any ideology of indices you want to apply. Without converting them to the same base, you will actually be applying these rules inappropriately. So we move on. The next thing you do is 2x, 3 raised to the power x multiplied by, convert this to base 2, that's going to be 2 raised to the power 2 in bracket minus y is equals to 2 raised to power 1. Then this is going to be 3 raised to power minus x times 3 raised to power 2, that's 9, in bracket 2y is equals to 3 raised to power 1. Now, in this case, don't forget the rule of indices. 2 raised to power x times changes to plus open bracket. Now, this 2 times minus y, that's minus 2y is equals to 2 raised to power 1. While the other one is going to be 3 raised to power minus x plus open bracket 4y is equals to 3 raised to power 1. We simplify further by saying 2 raised to power x minus 2y is equals to 2 raised to power 1. And this is 3 raised to power minus x plus 4y is equals to 3 raised to power 1. So in this case, then the next thing we do is equating the powers. Equating the powers. What this meant is that we cut out this basis on the other sides. The law of indices alongside with equality signs permits that the two sides, both the right hand side and the left hand side, could actually be eliminated in as much the bases are the same. So on this now, we could now equate the powers to be, we bring the powers down, it's going to be x minus 2y is equals to 1, then minus x plus 4y is equals to 1. On this base then, we could solve simultaneously. Now, solving simultaneously, this equation 1, this equation 2. Then, to solve simultaneously, we say that make x subject of formula, we have x is equals to 1 plus 2y, this equation 3. Then substitute 1 plus 2y for x in equation 2. So, in this case now, anywhere we see x, we substitute this. This minus, open bracket, this x, then we put 1 plus 2y plus 4y is equals to 1. So, open the bracket, we have minus 1 minus 2y plus 4y is equals to 1. Therefore, we have minus 1 comes here, then we have minus 2y plus 4y, that's going to be 2y is equals to 2. So, divide both sides by 2, we have y is equals to 1. So, therefore, you say that substitute 1 for y in equation 3. So, substituting 1 for y in equation 3 now will give us, it's going to give us, that's going to give us, we go back to equation 3, x is equals to 1 plus 2y. Substituting 1 for y, we have s is equals to 1 plus 2 into bracket, 1 plus 2 into bracket 1. So that's going to be x is equals to 1 plus 2, which is equals to 3. Can you see? Very simple. Very simple.